Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about chemistry of halogenated hydrocarbon CC6 Unit 1 Lecture 2. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. Today we are going to talk about nucleophilic substitution reactions SN1, SN2 and SNI mechanism with stereochemical aspects and effect of a solvent. So nucleophilic substitution reactions. So under that we have first reaction is SN1. So SN1 stands for nucleophilic substitution unimolecular. So here is the example CH3 whole 3 CBr plus OH minus giving rise to CH3 whole 3 COH plus Br minus. So here the rate of reaction simply depends upon the concentration of alkyl halide. So rate of reaction is rate constant into concentration of alkyl halide. So this mechanism. So first step is generation of carbocation. So this alkyl, so CBr bond will break on Br atom. So it gives Br minus plus the carbocation, tertiary carbocation. So this reaction is slow. So in the second step, once you generate this tertiary carbocation, so the nucleophile OH minus N or the base can attack from front side or from the back side. So as a result, you get two types of alcohol. So where you can have retention of configuration like here, and here it since it attack from back side, so here the alcohol that we get inversion of configuration. So in SN1 reaction lead to the racemization. So that means both inversion and retention of a stereochemistry taking place. So in this reaction, so what happens also, the frequent rearrangement also occur. So suppose we take this alkyl halide. So the loss of Br as Br minus giving rise to a carbocation. So what happens here? So since it is a secondary carbocation, so the hydride transfer can take place here. So that lead to a tertiary carbocation, so more stable. So that means, so in SN1 mechanism, the rearrangement that takes place leading to the more stable carbocation. So then the incoming nucleophile water can attack to this carbocation electrophile giving rise to the product ROH or alcohol. Similarly, elimination also can take place as a side reaction. So in presence of a base, so what happens? The loss of this proton giving rise to the alkene as a side reaction or byproduct. So as the stability of carbocation intermediate increases, so the amount of inversion decreases. The reactivity of alkyl halides in SN1 reactions follow this order: benzyl, allyl greater than tertiary, greater than secondary, greater than primary, greater than methyl halide. Generally, nucleophilic substitution reactions of tertiary alkyl halides follow the SN1 reaction mechanism. So this is the reactivity order for SN1 reaction. So tertiary greater than secondary, greater than primary. So here R stands for alkyl group. So the stronger the acid corresponding to a halogen, the better that halogen as a leaving group. So Hi is a strong acid and HF is a relatively weak acid. So the order of reactivity of alkyl halides follow this order: Ri greater than Rbr, greater than Rcl, greater than Rf. Similarly, mild nucleophiles like ROH or water tend to favor the SN1 mechanism. So here we talk about the solvent effect. So low concentration of nucleophile favor SN1 mechanism. So polar solvents like water, that is mixture of water and alcohol, is used in comparison to ether and alcohol mixture, which facilitates the ionization of alkyl halide. So here, so the carbocation is solvated by water. So solvation of carbocation and here the HX. Here you can see the solvation of anion by strong hydrogen bonding. So that means, so this RX bond will break. So you get R plus, the carbocation, plus X minus. So that means the hydrogen bonds between solvents and the leaving group facilitate the ionization process. So that means ionizing solvents favor SN1 mechanism, which efficiently solvate both cation and anion. Similarly, we can have polar protic solvent like water and ethanol, and polar aprotic solvent like DMSO, dimethyl sulfoxide, and dimethyl formamide, DMF. So here is the structure. Similarly, use of aprotic solvent. So nucleophilic substitution reactions which proceed slowly in common protic solvents proceed much faster and in high yields in aprotic solvents. So the reason is the protic solvent solvate the anion nucleophiles through hydrogen bonding and at the same time decrease the basicity or nucleophilicity of the nucleophilic reagent. So hence lower the reactivity of nucleophilic reagent in protic solvents. So now we move to the SN2 mechanism. So SN2 stands for nucleophilic substitution bimolecular. So here is the example CH3Br primary alkyl halide plus OH minus ion sodium hydroxide giving rise to methanol plus Br minus. So here the rate of reaction is dependent upon the concentration of alkyl halide as well as the OH minus ion concentration. So here it follows the second order kinetics. So here is the mechanism. So OH minus ion attack from the back side. So of the alkyl halide CH3Br. So here you can see we get this pentavalent transition state. So as long as this OH minus ion approaches to the minimal distance of carbon, so this CBr bond starts breaking. So as a result, you can get this alcohol plus Br minus. So since the approach of OH minus ion taking place from the back side, so there will be inversion of configuration. So the backside attack of nucleophile OH minus ion resulting the inversion of configuration in SN2 mechanism. So here is the stereochemistry. Similarly, electronic factors have no significant effect on the rate of reaction following SN2 mechanism. And the order of reactivity of alkyl halides in SN2 reaction, it follows this order: methyl halide greater than primary halide, greater than secondary, greater than tertiary, greater than allyl or benzyl halide. Generally, primary alkyl halides follow SN2 mechanism, and here no rearrangement occurs. And elimination as a side reaction is not so important. Strong and powerful nucleophiles like alkoxide ion favor the SN2 mechanism. High concentration of nucleophile also favor the SN2 mechanism. Solvent of low polarity favor SN2 mechanism. So now we move to SNI mechanism. Nucleophilic substitution internal. I stands for internal. So here is the example. So here we have this alcohol and it would react with thionyl chloride, SOCl2. So as a result we get this halide plus sulfur dioxide. So here the alkyl halide that we get, there will be retention of configuration. So here is the mechanism. So this alcohol has OH has lone pair of electron, can act as nucleophile. So oxygen lone pair will attack to the sulfur center and it will kick out Cl as Cl minus. So as a result you have this protonated species and here loss of this proton. So this OH bond will break on O plus. So as a result you have this chlorosulfide intermediate. So this will undergo simultaneous bond making and bond breaking. So this Cl can act as internal nucleophile. So this Cl attack as Cl minus and this O bond will break on here. So as a result you lose one molecule of sulfur dioxide here. So we can get this halide where there will be retention of configuration. So this mechanism involves internal transformation of the intermediate chlorosulfide referred to as SNI mechanism. Similarly, if we take this alcohol and we use thionyl chloride and pyridine, So there will be inversion of configuration. So it follows SN2 mechanism. So again OH lone pair can attack to this sulfur and it will kick out Cl as Cl minus, and here you have protonated species. So loss of proton giving rise to this chlorosulfide. So since we have pyridine in the reaction medium, so nitrogen lone pair will attack to this sulfur center and it will kick out Cl as Cl minus. So here we have this pyridinium ions intermediate. So again what happens? So this Cl minus will attack from the back side of this compound. So you will have your pentavalent transition state. So as long as this Cl and the carbon bond starts forming, it would depart sulfur dioxide and pyridine away. So as a result, there will be inversion of configuration and it would follow the SN2 mechanism. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. So for class 11th and 12th, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.